All right. Hello, all. I am very excited to discuss usually a fan favorite in this section, which is fractures. You have likely had some experience with the fractures, either having a fracture yourself, knowing someone who had a fracture, watching a sporting event where unfortunately a fracture occurred. So it's something that we've all heard of. So let's talk through some of the specific types of fractures and then what your body actually does in terms of fractures and some surgical interventions and things that we need to discuss. All right, so kind of just what I mentioned here. We're going to understand the differences between different types of fractures, and we're really going to get into the very basics regarding bone fracture repair. So what are kind of the major steps in terms of that? And then lastly, what are the types of treatments for fractures? All right, so let's start at the very, very beginning. Fractures generally are described as either open, and sometimes you hear this referred to as compound, or closed, aka simple. So, and you can see this pretty clearly right here in this image. Open fractures are going to break through this skin, as you can see here. So you have the two fractured ends. One of those, and sometimes both, would actually break the skin, whereas in a closed or a simple fracture, the fractures do not break the skin. So now while you can have some, very serious closed fractures, particularly in situations where a bony fragment can, say, puncture another organ, generally these open or compound fractures are generally more emergent situations than what you have with the closed. But again, you can have very serious closed ones as well. All right, so there's three major types. So kind of these are going to be the two major categories, the open and closed, and then within those you can have these different types here. So you're going to have comminuted, and kind of keyword here is shattered. So what will happen here, and colloquially we'll hear this referred to just as shattered bone. And so a portion of the bone is going to be broken into numerous pieces, so shattering, as you can see here. So you could have fairly clean breaks on one end, but this middle portion is many different pieces of bone. A comminuted fracture is typically much slower to heal, and that kind of makes sense. If you think about trying to get those pieces, those shattered pieces in alignment to allow for that fracture repair to occur, that's a lot more difficult than what you would have in, say, a cleaner break. An impacted fracture, as you can see here, will typically have one fracture end that is kind of driven into the other end. And you can kind of see that or kind of conceptualize that right here. Say this is one of the fractured ends and it's driven hard into this second fractured end. A green stick fracture, I think, is one of the more interesting types of fractures where you have an incomplete transverse fracture, as you can see here, but generally this other side, the side that's not fractured, will bend. And I don't think this image quite shows it as clearly. So you have a very typical fracture, but it's not complete. And then the opposite side, the non-fracture side, will bend but not completely break. And this fracture is called a green stick fracture because of the similarity. If you think of like a newish green twig and you try to break it, sometimes you'll have a break on one side and the rest really just kind of bends but doesn't completely break. And that's what this is kind of named after. A green stick fracture only occurs in juveniles as their bones have not fully formed or calcified and contain more organic than inorganic material. Thus, you get that bending. All right, let's talk a little bit about repair of bone fractures. Now, as soon as a fracture occurs, the bone and surrounding area almost immediately tries to heal itself. And it does so in this relatively typical process. So I do want you to understand the very basics, these 1, 2, 3, 4, right here. So let's start with this first part, or the formation of a fracture hematoma. So because remember, bones are very vascularized, because blood vessels associated with around the fracture are also going to be broken with a fracture. That will typically allow for a fracture hematoma to occur, or a collection of blood in this area, and that will form around the fracture site. The hematoma can form around 6 hours after the fracture, give or take. And because the blood supply has been affected in this particular area, bone cells aren't getting that sufficient supply of oxygen, in this region, or the other nutrients associated with blood. So bone cells will actually begin to die around the fracture location. Now, new cells from the periosteal region will kind of move into this area with time, called fibroblasts or chondroblasts. And you'll get what's referred to as the formation of a fibrocartilaginous or soft callus. So this isn't hardened bone. This is kind of a soft callus in this region. That, with time, will eventually be replaced by a bony callus. And that bony callus typically is much larger, or not much larger, it's larger than what you typically had the bone look like in that region. So it's kind of more of a mounding of bone around where that fracture occurred. Now, with time, that bone will remodel and kind of get back to its original shape and size where that fracture occurred. Now, that can take years in order to get that. Sometimes you never get the full or the complete movement back to what the bone looked like originally. Sometimes you do, depending on how long you've had to heal. Did that blood supply kind of become refreshed in that region? That type of thing will have lots to do with whether you get the bone to look kind of more what it looked like pre-fracture. But these are the typical 4 steps in terms of repair of bony fractures. Now, the treatment for fractures depends on numerous factors, including the type of fracture that occurred, the age of the individual that had the fracture, what bones were involved. That's something else that's fairly huge. But the ultimate goal in terms of treatment for a fracture is to realign the fractured parts. Because if you get that realignment, then you can have that formation of that fibrocartilage callus. Then you can get the replacement of that with a bone, or that replacement of the fibrocartilaginous callus with bone, if you have good alignment of the bones. So what will often happen is immobilization to prevent refracturing or misalignment. Now, this can be done in one of 2 ways. You can have what's referred to as a closed reduction. So the fractured ends are going to be aligned by manual manipulation. So just kind of making sure that these stay aligned, you kind of move this back into place, but importantly, skin stays intact. But with an open reduction, those fractured ends are going to be realigned by surgical intervention. So say this space right here is actually too far apart to do this through manual manipulation, then you would have to do some type of surgical intervention, and that would be an open reduction. Whereas with a closed reduction, the skin would stay intact. So typically you would not have that with something that's an open fracture. But a closed fracture can have either a closed reduction or an open reduction. All right, excellent. Let's go through a question together. So you receive a report from the radiologist concluding that you have shattered the mid-shaft of your right femur, so that thigh bone. What type of fracture have you most likely suffered from? All right, so pause the video. Try to answer this on your own, and when you're ready, hopefully you've landed on A. And really, when you're looking at this question stem right here, the key term really is shattered. Anytime you think of a shattered fracture, you need to be thinking a comminuted fracture. You can have some fracture in terms of an impacted, but not necessarily so. Remember, that's more about the 2 fractured ends kind of being driven into one another. A green stick generally doesn't have shattering. You'll have a fracture and then bending on the other side that occurs with juveniles. So comminuted A is the correct answer here, and hopefully you feel comfortable regarding that. Most excellent. Thanks for your time and attention here, and I will see you in the next video.